Yes, good morning, students. As per the guidelines given by the JNTU Kakinada, we'll start the 2-1 semester. In this semester, I will teach you the subject called data structure. Here, myself, I am Kishore Babu, working as assistant professor in the Department of Computer Science and Engineering in Guntur Engineering College. Today, we will discuss about the introduction to data structure. Here, let us discuss what do you mean by data structure, right? How can we organize the structure? How can we store the data into the memory of a computer, right? Uh, and the classification of data structure and all, right? Let us discuss one by one by using this PowerPoint presentation. Coming to the definition, the data structure is a way of collecting and organizing data in such a way that we can perform operations on the data in an effective way. That means the data structure is nothing but it is a collection of data elements, right? And organizing the data. That means we can store the data in a systematic manner so that it is easy for performing the operations on the data in an efficient way. That is called as data structure. And it is a logical way of storing data. The data structure is also say that it is a logical way of storing data, and it also defines mechanism of retrieve data, right? We can store the data in an effective or in a systematic order. Whenever we want to require the data, we can retrieve the data easily. That is called as data structure, right? Next, what is the need for data structure? The data structures are important way in organizing data in a computer. As already we said that organizing the data in a systematic manner in a computer memory. It has a different way of storing and organizing data so that it can be used efficiently. Yes, we can store the data in different ways. That's why it can be used efficiently. It helps us to understand the relationship of one data element with another. That means by using this data structure, which helps us to understand which type of relationship that established between one data element to with the another data element. It helps to store a data in logical order, right? And it stores the data that may grow and shrink dynamically over time and allows efficient access. Right? When we use data structure, here the data may grow and shrink automatically, dynamically at runtime, right? And allows efficient access. Here, see this diagram, classification of data structure. This given diagram will shows the classification of data structure. Right, this data structure is classified into two types. One is primitive data structure, that is nothing but primitive data type, and non-primitive data structure. And this primitive data structure means the data types that are called as basic data types. Like it can be classified into integer, real, character, string, pointer, etc. And coming to the non-primitive data types, mainly it is classified into arrays, list, and files. Right. This list is classified into linear list and non-linear list. This linear list is again classified into linked list, stacks, and queues. And non-linear list is classified into trees and gaps. Here, the data structure is mainly classified into a primitive data structure and non-primitive data structure. The non-primitive data structure is again classified into linear data structure and non-linear data structure. Where the linear data structure means we can arrange the elements in a linear order, right? That is called as linear data structure, where the examples are arrays, linked list, stacks, and queues. These are come under the category of linear data structure. Coming to the non-linear data structure, here the elements are arranged in the random order, right? So the examples for this non-linear data structure are trees and graphs, right? First one is primitive data structure. The primitive data structures are the basic data types that are available in most of the programming languages. In all the programming languages, we know what are the basic data types. Those basic data types are called as the primitive data structure. The primitive data structures are used to represent the single values, whether it may be integer value, character value, string value, boolean value, etc., whatever it is. And coming to the non-primitive data structure, the data structure that are derived from the primary data structure, that is known as non-primitive data structure. These data types are used to group, to store group of values. Like the examples are arrays, unions, structure, linked list, stacks, queues, etc. Where in this we can store the elements in the form of group. The group of values can be stored here, right? Linear data structure means in linear data structure the elements are stored in sequential order, right? The linear data structures are arrays, linked lists, stacks, and queues. Just what is an array? An array is a collection of data of same data type elements which are stored in the consecutive memory location and is referred by the common name. That is called as array. As we know that the array is a collection of homogeneous or same data type elements, and all the elements are stored in the memory consecutively side by side, right? And the array, this memory is referred by the common name that is called as array name. And next one is linked list. The linked list is a collection of data of same data type, but the data items need to be stored in consecutive, need not to be stored in consecutive memory locations. Whereas in case of array, it is a collection of same data type elements, but all the elements should be stored in the consecutive memory location side by side in the memory. But coming to the linked list, it is a collection of data elements of same data type, but the items, the elements should not be stored in the consecutive memory location. They can be stored at different locations. Stack. Stack is a data structure. It is called a linear data structure which works on the principle of last in first out, right? In which the insertions and deletions are taken place at only one end, which is called top of the stack. Right, that is the definition of stack. And queue is another linear data structure which works on the principle of first in first out, and in which the insertions can be taken place through one end, that is called as rear end, and the deletions taken place at the other end, that is called as front end, right? Coming to the non-linear data structure, the elements are stored based on the hierarchical relationship among the data. Such that is called as non-linear data structures. The examples for non-linear data structures are trees and graphs. Here, trees. The trees are used to represent data that has some hierarchical relationship among data elements. That is called as a tree. Generally, in case of trees, the root node is at the top and the remaining nodes and the links are at the bottom. And coming to the graph, graph is used to represent the data that has relationship between the pair of elements, not necessarily hierarchical in nature, right? So the graph is used to represent data that has relationship between the pair of elements. So it shows the representation, the relationship between each pair of elements, right? For example, airline routes, flow chart, graphs for planning projects. All these are the examples for graphs. And the operations that are performed on the data structure, whether the data structure is either a linear data structure or it is a non-linear data structure, we can perform the following operations that are insertion, that is adding new element into the data structure, and deletion, it is removing the data from the data structure, and searching, it is finding location of data within a given data structure. We have to find out the given element in the data structure. And sorting means arranging the data in some logical order, whether it may be increasing or decreasing order. And traversing, the data structure is accessing each data only once. That means traversing means you can accessing each data item, and we can move from one element to another element. That is called as traversing. And merging, it is the combining of two similar data structures into single. These are the operations performed on the data structure. And let us discuss the linear data structures or arrays, linked list, stacks, and queues. We will discuss briefly about the arrays. Array is defined as the set of a finite number of homogeneous elements or the same data type elements. As we discussed on the previous slide, the array is nothing but it is a collection of homogeneous elements or same data type elements. It means an array can contain one type of data only, either all the integer values or all the floating point numbers or all the characters. Okay. So this is how we can declare the array. The data type followed by array name. Within the square brackets, we have to mention the size of the array. Here the example is int r of 10, where ARR is nothing but the name of array and the array size is 10. Right? Int specifies the data type, and ARR is the name of array, and the number specified inside the square brackets is the number of elements that can store. Right? So this is also called as length of array. This size is also called as length of the array. Right. So this is the syntax. Data type followed by array name. Within the brackets, square brackets, we have to mention the array size. And this array can be initialized in two ways. This is the first way of initialization. Just after the array, we are assigning the values in the braces. Here we are assigning the values 2, 4, and 8. So the size of array is 3, where the 2 is stored in the 0th location, 4 is stored in the first location, and 8 is stored in the second location. The second method is declaring the array first and then assigning the values to its elements. So like this, here we are declaring the array n of 3. After that, for each location, we are assigning the value. So n of 0, which is assigned with the value 2. N of 1 assigns with the value 4, and n of 2 assigns with the value 8. Like this. This is how we can initialize the array elements. Right. This is a small basic program. Here we can read the values into the array, and then we can print the values into the on the screen. Right. Here the size of array can be taken as 10. Here we are taken for loop for I equal to 0 and 0 is less than 10. So the condition is to execute the loop statements in the loop. So enter the value of n of I. Here the I value is 0. So n of 0. Right. Cin. Read the value into n of 0. Assume the value is 10. Next, I plus plus I becomes 1. 1 is less than 10. The condition true. Again, in the second iteration, enter the value of n of 1. That means read the value into n of 1. Assume it as 20. Next, n of 2, 30, n of 3, 40, and so on up to n of 9. Okay, the loop iterates for 10 times. And after reading all the values into the array, just by using this for loop, we can print all the values of an array. For that, this is a small sample program using C++. This is the array representation, where the array can be the elements can be stored in the consecutive memory locations like this, and the array elements can be represented by using the index values. These are the index values. The index value starts with 0 to n minus 1. Total, we are storing 8 elements. The array size is 8. So the index value starts with 0 to 7. That is 0 to n minus 1, where n is the size of array. Here the size is n. That is 8. N minus 1. 8 minus 1 equal to 7. So the index value starts from 0 to 7. Okay. Yes, in case of C programming language, we can read the values of array by using the scanf function, and printf is the function which is used for displaying the elements of an array. Whereas in C++, we can use the cout to print the values, and cin is used to read the values into array. And these operations performed on array. Following are the various operations that are performed on the array. That is traversing, that is moving from one element to another element. Searching, we have to search for a given element in the array. And the insertion means adding new element into the array. Deletion means deleting an element from an array. Sorting means arranging all the elements in the array either in the increasing order or decreasing order. And merging means combining two arrays into a single array. And next one is linked list. It is a linear collection of data elements. It has two parts. One information and another one is linked part. Right. The linear the linked list is a collection of data elements where the data element can be called it as a node, and each node is having two parts. The first part is called information part or data part, and the other part is called as a link part or address part. This address part will contain the address of the next node. Right, this is called linked list. This is how we can represent the linked list. Right, this is the first node which contains two parts. The first node contains the data and the second node contains the address of the next node. Here the data is AAA, and this is the address part which contains the address of the second element. And this is the second node which contains two parts. The data part, data is BBB, and this is the address part which contains the address of the next node. And this is the third node which contains two parts. This is data part which contains the value CCC, and this is the address part. But this address part is taken as null because after the third node, no more nodes are available. I think that means it is the last node in the linked list. The last node address part should be represented with null value. Then the compiler will understand that whenever the address part is having null value, that means that node itself is the last node in the linked list. Here head is a pointer which always stores the address of the first node. Right. This is how we can represent the linked list. And following are the different operations performed on linked list, that is traversing, searching, insertion, and deletion. Right. And next one is the types of linked list. The linked lists are classified into different types like single linked list, double linked list, circular, single circular linked list, and double circular linked list. You can classify the linked list in these different ways. And next, coming to the stack. Stack is an ordered collection of elements like arrays, but it has a special feature, means that the deletion and insertion of an elements can be done only from one end, that is called top of the stack, that is TO. And the stack is the data structure, linear data structure, which works on the principle of last in and first out. That means the last element that is inserted into the stack is the first element that is removed from the stack. That principle is called as last in, first out. Right. And we can perform two operations on the stack, that is push and pop. Push means adding an element into the stack, that is inserting an element into the stack. We can call it as push here. And pop means removing an element from the stack. Right. That is called as pop operation. That is inserting and deletion. And next one is insertion of element into the stack is called as push, and deletion of element from the stack is called as pop. Just to discuss. This diagram shows this is a stack which contains two ends. The bottom end is closed and the top end is open. We can push, that means we can insert the elements and delete the elements from the stack through only this end. This is called as top of the stack. Right. This is how we can represent the stack. This stack can be implemented in two ways. We can implement the stack by using arrays and by using the pointer. Right. The queue. Queue is a linear list of elements in which the insertion can be done at one end, which is called as front end, and deletion can be done another end, that is known as rear end. Right. The queue works on the principle of first in, first out. Just we know that the queue line, where in the queue line, the first person that entered in the queue is the first person that come out of the queue. Right. So the queue is a linear data structure which works on the principle of first in, first out. Right. The people standing in the railway reservation row are an example of queue. The below diagram shows the representation of queue. So this is queue which contains two ends. This is called as front end. This is called as rear end. Already we discussed that if we want to insert an element into the queue, it should be inserted only through this rear end. If we want to delete an element from the queue, it should be done only through the front end. If we want to delete, the first element should be deleted in this way. If we want to insert, we can delete the new element in this way through rear end. Right? This is the representation of queue. We can perform insertion and deletion operations on the queue to add a new element into the queue, and deletion operation is used to remove an element from the queue. We can implement the queue in two ways, using arrays and using pointers. Here, pointer is nothing but by using linked list, we can implement the queues. The queues can be stacks and queues can be implemented in two ways, by using arrays and by using the linked list. By using arrays, we can call it a static implementation. By using a linked list, that means using pointers, we can call it as the dynamic implementation. And next one is a tree. Tree is a nonlinear data structure which organizes data in the hierarchical structure. Right. Already we discussed that the tree is a nonlinear data structure where the elements are arranged in the random order and which organizes the data in the hierarchical structure. A tree can be defined as finite set of elements, and each elements or items we can call it as nodes. Tree represents the hierarchical relationship between the various elements. There is a special data item at the top of the hierarchy that is called as the root of the tree. Already we discussed that in trees, the root is at the top and at the bottom there are the nodes and its links. This is the representation of a tree where A, B, C, D, E, F, G, all these are called as nodes. These elements are called as nodes. The node can be represented in the form of circle and which contains the value. Right? That is called as the node. This is the tree representation, hierarchical representation, where in the top of the hierarchy there is only one node that is called as the root node. After that, these two are called the left and right child of this A, and these two are the left and right child of the node B, and F and G are the left and right childs of the node C. Like that. This is the hierarchical representation of tree. Right. Next, the operations performed on the trees are insertion, deletion, and searching. Inserting means insert a new element into the tree and deleting an element from the tree, and we can search for a particular element in the tree. So these are the three operations performed on the tree. And next one is graph. The graph is nonlinear data structure. It contains a set of points known as nodes and set of links which are called as edges. Here the edges are used to connect the vertices. Right, the graph is a nonlinear data structure which contains the nodes and edges, and nodes are nothing but vertices. By using these edges, we can connect the nodes. And the definition of graph is a graph G of V comma E is a set of vertices V and the set of edges E. Right, these vertices are connected by using these edges. That is graph. This is the graphical representation. All these are called as nodes, and these every pair of nodes can be linked with an edge. This line is called as an edge, and this node is called as node, or we can call it as vertex. This is how we can represent the graphs. And the following are the operations performed on the graph, that is searching, insertion, and deletion. Right. So this is about the introduction